So this is the Git checkout as you get it. As a matter of interest, I think when we develop, we use another Git checkout with the not GPL bits like Workbench, etc., and the audio agent, and we check out the GPL part into that as a subdirectory. So we are when we make a release, we are actually building it right off the set.
Against the GPL repository.
Just with some extra bits, and the build system goes in.
Don't break it.
You can fix it.
Right, yes, it is Git. So, lots of directories in here, and most of them aren't that reasonably uninteresting to you. Anything beginning with plug is a plugin. It's an agent. That's where our agents live.
If you write one, that's where it'll end up. Is that right, Jim?
Yeah. Yes. Or we'll have a
Should we
contrib
maintain
section.
the naming thing, or do you want us to name them slightly so people know it's not an official one?
I've been thinking about just actually creating a plugin directory and moving all these in anyway. So
Stick with it for now,
Yeah.
and then we can always rename it later.
yes. So I think it's pretty obvious, reasonably, what these are.
And you can see it's quite traditional to miss a random letter out of a word just to make it more difficult to remember.
If it's shorter.
Yeah, it's a short.
Vowels are so 20th century.
Yeah, it makes
Yes.
it more compatible with our style guide.
Yeah. So we have the arranger and control. This is the AU VST host. Keyboard is the alpha and tau keyboard manager. Language is the interpreter. Loop is the metronome and the drummer. These things tend to hold a set of related agents, each of these. And the clicker is in there too. MIDI input and output in here. The OSC one. Hookabird is the Pico keyboard manager, as opposed to Ukabird, which is the micro keyboard manager you saw, which may or may not work. We haven't had a micro for a while. So. Synth is various sort of modular simply bits like the Ahudza and envelope generators and things. SDK are the clarinet, etc. We use there's SDK is a toolkit from
CCRMA.
What was plug simple again?
Julius O. Smith, you know Julius O.
I've
Smith?
got that here for you.
He's professor at Stanford. Really good at DSP.
Oh,
It's a C, it's a C+ library full of
there's a lot of stuff in there that doesn't seem to make it through to.
no,
What's-
we are
Go ahead, have a look at it. Mandolin.
yeah. We don't ship. We obviously can't make this part of our public API. But you're free to copy. You could just copy the whole thing into your
Yeah,
thing.
use the SDK if you want. it's a very, very liberal
I didn't
license.
realise that was all in there.
It's a very liberal license.
Yeah, I looked at it. It's
There's one or
It's
two
interesting, so
comments.
it's not as good sonically as you think. It's good starting points. So
Yeah.
the blown tube model is where we kind of started off with clarinet, but it was 6 months before it sounded like anything like a clarinet. So it's you get something that's part way there, don't you?
But there are very useful tools like filters that remain stable as you vary their parameters and things like
Yeah.
that, which is
Yeah.
quite.
It's handy.
If you'll find if you start building a filter, that's hard
Yeah.
to do.
It's a DSP difficulty. You've really got to know your stuff, and they do know their stuff.
Well, it's the solved problem you
It's
have
the
to
solved
solve.
problem. Yes.
There's a couple of interesting comments in some of those modules that suggest that in a commercial release there may be issues. I don't know whether you-
Well,
I'm
no,
guessing
that's
you've
patents that are so long expired now. That's from when it was, because it was 10 years ago that
Fine.
stuff was released.
Cool.
So, and that's patents, Yamaha patents,
Yeah.
particularly on the waveguide models. But I think they've expired for those now, so we wouldn't have it in our stuff if.
I figured it was.
misjudged.
Plug primitive is Gertz started a set of kind of primitive signal agents that do things.
Things like the latch.
Latch and all.
Yeah.
The recorder is the recorder. That's pretty much
Yeah,
rig.
dragons.
Yes. Rig is the new rig agent. Sampler are I think it's the Holy Trinity. Of just the sampler oscillator itself. The sampler, the cycler agent, and the Ahudza agent kind of go together in this triple that you shouldn't really break up unless you really want to.
So was the third one sampler cycler?
and the AHUDSA,
Oh yes, yeah.
the envelope
No.
generator.
It's a consequence of the way that sound font files work, because each sound font sound has its attack, hold, decay stuff.
Yeah.
And that's layered, so each layer sample can do that. You can only choose the parameters according to the incoming velocity, because it's quite MIDI-centric, the original idea, because it's samples, which actually work in a kind of MIDI-centric way. And because those parameters are chosen at the point of playing, then the AHUDSA has to be dynamically set by the sound font oscillator. So it's a little funny little loop of parameters, all to keep it moral, it all has to sort of do it in real time.
And cycler sits on the front to give you kind of piano behaviour about if you can make it, if you're hitting the same key, you can damp the original note out and start a new one. And
so it works the dampers and does stuff.
Yes. So those are the plugins, which are the uninteresting bits. These ones, Plug Simple is essentially at the moment all of the agents that don't have any C++, because all the C++ they use is in one of these other libraries. Actually, that's things like,
What's in there?
well, lots. Things like strummer, scheduler, key group.
It's a lot of PNG for some reason.
Yeah, well, lots of odd pictures that ended up in there.
I think it used to display icons in the browser.
It did use
Yeah.
to display icons in the browser, yes.
That's why they're still in there.
Okay. Does that still work out?
I think you might occasionally get one.
I think you could clean them out.
Yeah, no, I mean to really. Things like the key group. Now, we're probably going to end up with C, moving C into there. But, anyway, the app directories. These are applications. This is the old browser, the Python Wooks thing. Odd command line applications like BCAT and BLS,
Debuggy
things like
stuff
that.
you guys.
Yes, generally debuggy stuff. The Commander again, which is a Python Wooks, and Eigen-D, which is most part of Eigen-D. It's the UI part. Then we come to libraries, which are Oh, by the way, all of these directories tend to double up. They can be libraries and Python modules at the same time. We tend to use a directory as possibly both. If it has init.py in it, it's a Python module. If it has headers in it, it's a include directory, or both. So libalpha1 is the old alpha. It's basically a support library that deals with getting it off the USB and decoding.
Was that for the Mark 1 alpha?
Yes.
Yeah, don't go there. It's just
Yeah.
Of which there are only two.
Yes.
those manual beast really. So.
Yeah. LibAlpha 2 is the same, but for the Alpha 2s. Both the current Alpha 2 and the legacy Alpha 2.
They both live in a libAlpha 2, do they?
Yes. FFTW is MIT's FFT library, which we do use
In the convolution.
in the convol.
That's all that's the convolver uses.
Yeah, it's the only thing that does, I think, at the
We'd
moment.
like to change that library, wouldn't we, at some point?
Yes. Looking for another convolver to use.
Why is it just inefficient? Why?
I don't know, really, actually. We decided we wanted to change it, but I'm not
There
sure
was
why.
a really good reason at the time, but I can't remember it.
Yes.
If
Neither
we
can
go
I.
into the background, then it will re-emerge.
Siri might remember.
There will be.
This is Juice, which we compile Juice as a library for use in Eigen-D and in plugins, so you're sharing the same one. Stage and Workbench both use Juice as well, but they actually use their own copy of Juice. Juice is distributed basically as one honking great C++ file, hundreds of thousands of lines, and you just embed it in.
It's really one file.
Well, the tree is loads, but then he has this amalgamator that glues it all together. It makes it very convenient because you just drop the C and the H
Big
files
file.
onto your thing.
So that's why my machine stops dead when it compiles that. Then it's
Oh yeah, it
fast.
takes forever to compile.
Right,
Yes, but we Workbench and Stage both have their own versions, so that we don't actually. They're not coupled. The Juice in here we use the VSTs and and AUs and stuff like that, which that's where we find problems, and we do communicate with Jules quite a lot about those. So it's harder to stay on the leading edge. It's easier we can change this whenever we like without messing up Workbench and Stage then. So that's why we keep different versions in there. LO is the LO OSC library, heavily hacked because it is quite broken.
So that's now forked, basically, is it?
Well, there's lots and lots of hacks for Windows and for old threading bugs and things. We have posted them some patches, but never had any response. So, yes, fork.
Source code.
The micro library for dealing with the micro and for the Pico. This is a library that is effectively the juice controls for the routing matrices. They were in one of the other libraries, but we factored them out because we don't like our libraries to depend on juice in general. We'd like to keep them juice free apart from the high level applications. But these are shared, so we factored them out.
So even in the juice directory, it's encapsulated, but not directly using juice data structures in the rest outside this juice?
Yes, these use juice and use the other libraries, so nothing depends on these apart from the plugins that have those UIs in. We use juice directly. We haven't factored it out or encapsulated it or anything.
Yeah, so in the app Eigend there are juice calls, not a
Yes.
wrapper in between.
Yes, there are. Juice is already, it's quite a fat interface. It would be quite hard to factor it, I think. Lib sample rate is the SRC, the secret rabbit code sample rate converter library,
Which is quite good.
it's quite good, and it's open source, and we do have a commercial license for it as well. So again, we've got it on this dual license, but it's free to distribute. We use that for resampling the headphone and microphone.
Yeah, the isoizers are our own code, aren't they? We wrote that.
Yeah, but we don't do sample rate conversion in those yet. At some point we will, and probably use this, in fact. Then we come to the rest of them, these PI, which are still historically named from when we weren't called Eigenlabs.
We were performance instruments for the first 6-7 years of our lives.
But it's way too hard to type, and you try phoning someone up and explaining that your email address is jim@performance-instruments.com. You never receive any emails, so it's quite wearing.
We did try to buy pi.com, but it's owned by a very, very strange man in California. He was a lawyer. And when we wrote to him to say, would you like to sell it? He wrote back and said, have you got any money? We said, yes, we could probably afford whatever, a sensible price for this. Because it's a two-letter domain, it's not going to be cheap. This is 10 years ago, so it would have been a lot more reasonable than it is now. And he wrote back and said, no, you're all pigs or something. He said, I want loads of money. And that's the last we heard from him. It was just very weird conversation. So anyway, sorry, history.
Yes. Anyway, so these PR things are core libraries, as it were. Now there's a distinction in the system between code that runs in an agent hosted by Eigend and code that doesn't. Most of the code that runs inside an agent assumes some things about its environment. Specifically, when you get calls into an agent, it sets up some thread local data for kind of context processing to make things easier to find. So if you need to create a state variable, you can just do it rather than having to pass context down from the top. So in general, code in PIW is written like that. Code outside of PIW is not written like that. Which means stuff in PIW is less generally useful. If you're going to use that code, you need to create this environment first. Now, PI bel canto, let's look at that's the simplest one. That's just really a few header files with some basic kind of network protocol constants. The lexicon itself, which is a text file which the build system converts, and plugin.h, which is actually the C interface between Eigend and its agents, which is quite boring. Lots of structures and callback functions. So all the things we talked about yesterday, things like state variables, indexes and stuff, their basic interfaces defined in here. You never use them like this. There are C++ wrappers elsewhere, which we generally use. PI embedded has a few odd functions which don't depend on PIW, but just kind of do things like format wire messages. And it's called PI embedded because it's the remainder of a library which was really written to run, did the protocol core, and was written to run on DSPs and constrained environments and things like that. So
no floating point.
yeah, it is.
For example.
It's just, and there used to be a lot more in there, but it's gradually withering away. The PI is a high-level Python module, which is where most of the things you do inside agents will live. We'll go there last, I think. PI GUI is uninteresting. It just has a few fragments to help when you're trying to write an agent, a standalone agent, and you're writing it as a Wux widget.
Deprecated.
Yeah, so things like the commander and browser use that as just to kind of get this concept
Please don't
set up.
use them.
Well, those deprecated will probably delete it at some point, so you won't use it.
Because
It may give you Greek in the future.
yeah.
So.
These things, because these things are standalone agents, they have to do. They actually have. They use a lot of the same code that Eigenharp uses to create the kind of context to use PIW in. So there are event loops and things they use, and this stuff contains ways of kind of gluing the event loop in with the GUI event loop and boring stuff like that. So we get to the main parts, the C-level parts of what we consider our API are PIW, PI agent, and PI cross. So those three libraries. PI cross is generally just cross-platform abstractions for things, and only tend to put in only things that really are different across Windows and Linux and MacOS. Atomic is atomic operations, things like atomic compare and swap, and atomic increment and decrement and stuff. Things we use for reference counting and some of the other trickery we do. Backtrace is just kind of error functions. CF run loop is a helper for Macs. It lets you create a thread that is also a core foundation run loop, which is important if you're doing some Mac-y sort of things. Config is just a file that detects what platform you're on and sets various headers. You'll find most things that need the if-def what platform they're on include this to make sure they've got some stuff. Endian is just things that depend on what endianness you are. Error is, I don't know.
Do we have errors?
Well, it's an exception. Some sort of assertion operators and things we use. FastAlloc is the interface to our fast allocator. Eigenharp uses because you can't malloc things in the fast thread because it might hang up your thread, and because we need to use locked memory, this will get you memory that is locked and won't block to do it. It does it quite crudely by maintaining queues of different blocks, and it has a background thread which essentially tops up these queues to make sure that they have memory available in them. And it maintains kind of queues of different sizes and works on the idea of allocating a big block and then just continually dividing it into. Flip-flop is one of our facilities for communicating with the fast thread. One way of, since you can't use mutexes between the fast thread and slow threads, because then the fast thread might hang up waiting for the mutex. You can't do that. A flip-flop is a way of maintaining two copies of a structure, two copies of something, which can be anything. The fast thread can lock a copy of it. Because there are two copies, whatever you're doing, there's always one copy available to the fast thread. The fast thread will get the current copy. It's only allowed read-only access to it. And from the slow thread, you can then work on the backup copy and call an exchange operation to slide the two over.
Can you call the exchange operation from fast thread as well?
No. This is a slow thread.
So this is slow thread to fast thread
Yes.
communication.
So essentially, it's for things where the slow thread is building some structure which the fast thread uses. And if you want to change that structure, you can build the new structure and then substitute it. But when the exchange operation returns, you know that the fast thread will no longer be using the old copy, and it will be using the new copy from then on. And then you're free to go and change the other copy.
Give me an example of usage. I'm using it in the finger. I read the fingerings out of the fingerings file. You choose which one out of the fingerings file you want in bel canto. And when you do that choice in bel canto, the verb populates one of these data structures that are a part of a flip-flop and then flips it over once it's set. So then the actual fast thread gets a different fingering loaded into itself.
It's quite a convenient way of doing things, but the big limitation is, of course, that the fast thread's copy is read-only. So anything, if the fast thread needs to mess with it, then you can't use a flip-flop. It's a template class, so you can flip-flop anything. You can flip-flop a map of sets of things if you want. As long as it's a sort of first-class C object with copy same kind of thing. If it can go into an STL container, then you can use it in a flip-flop.
Yes, the fast thread require a lock, so the exchange does not happen while it's still reading.
The fast thread, there's a guard. The way it's actually used, there's a guard object that's used. So the fast thread will create a guard object on the flip-flop, which effectively locks it to the slow thread. Just the way it works is because there are two copies, even during an exchange operation, there's always one of them the fast thread will get, so it never has to wait. The guard object is the lock. So while that lock is in place, the slow thread will not be able to exchange. So the exchange will hang up until the guard is released.
So it's blocking.
It's effectively a lock, yes.
So the switch operation is blocking, or is it just...
The switch operation, the exchange operation is blocking, yes. But then
It's never going to block for longer than a clock tick. So.
And that's the slow thread.
no, it'll block for as long as the fast thread has the guard in place.
Yeah, but that's only for a tick, right?
Well, it depends on the fast thread, depends on what you do. But
Okay.
it's the slow thread that's blocking here. It's not going to block for very long because the
That's
fast
what I
thread
mean,
never.
yeah, but presumably it's not the lock basically released at the end of the clock tick, or is that you just have to manually do that?
Well, the guard object, it's the construction takes the lock effectively, and the destruction gets rid of it. The fast thread never does anything for very long, so it's.
Could hold it, which makes no sense.
Yeah.
Float are some odd kind of floating point utilities. There are some approximations to different kind of expensive operations, like kind of exponents and logarithms and things.
So you sort of simplified it to make it quicker, because the accuracy is not really much.
Yes. There's also some primitive wrappers around kind of accelerated DSP functions, some kind of some things like sort of correlation and stuff like that. If anybody knows of a good cross-platform library for that sort of stuff,
For vectorizing.
yeah, it would be kind of good, But
The Q, just some Q stuff is pretty good.
that's Intel specific, though, isn't it? No, that's the NVIDIA.
Isn't that graphics?
Yes, GPU. Yeah, so the Q stuff has been done for the graphics arrays and stuff, but with OpenCL now, because I think they've got libraries which do it for using the Qs on the Intel chips and stuff.
The Q is,
Sorry.
it's actually separated. There's a Qt core that has even a more liberal license. You can virtually, you can even use it in a sole device as long as it's not visible on the surface. And this Qt core is definitely also running on ARM.
We're talking
I'm
about
talking about
CUDA, C-U-D-A.
Not
Sorry?
No, QT.
QDAM.
CUDA.
CUDA, QDAM. It's a performance thing for array processors.
Do you know what its licensing is? Offhand?
The library's old now. I haven't
Worth looking at.
It's-
But I guess if you were writing an agent, that might be worth looking into if it was doing something DSP specific. It would depend on the licensing of your agent, then I suppose. Right. Functor. We use functors heavily. By functor, I mean something that's callable, a function-like object. And a functor here it's a template wrapped thing that, templated is in terms of what its return value and parameters are, and they are copyable objects because it's effectively they're reference counting pointers to a back end that implements the actual function. We use those very, very heavily, and we have some sort of standard function types, things like something that doesn't return and doesn't take any arguments, returns a data, takes a data, that sort of thing.
Is this a mechanism by which you can achieve the same thing in C++ that Python more or less does?
Yes, and one of the reasons
where
is that
you can call the thing, but you can pass it around as a first-class object of its own.
yes, yeah. And the reason we use them heavily is because for the types we've defined, we've also defined wrapping functions so that if you have a Python callable, you can convert it into a functor and pass that into C++ and call it from the C++. Or you can define a functor backed by a C function and then pass it back out to the Python and the Python can call it. So you get this transparent callable thing, which is a very, very, very convenient way of doing some stuff. We also have some other tools in PIW for things like if you have a function that's meant to be called in the fast thread, you can adapt it to something that you can call in the slow thread and it will automatically post it to the fast thread and wait. And the opposite of if you've got something that's slow callable, you can give it to the fast thread and it'll drop an asynchronous call to the function into the slow thread. Things like that. Quite useful, they can end up as quite useful tools to do things.
Also pass functors between agents
No.
as a stream.
No. They're used at the code level. But agents are logically separated by a network. If you're going to call things between agents, you use RPCs.
Yeah. So in this case, the functor would have existed on the nodes.
Yeah, well, we haven't. It would be possible to write a functor that did an RPC. I suppose. The thing about RPCs is they are asynchronous. When you call an RPC, you can't hang around and wait for it to come back because it might take a while. It's going off some other place. So they're not. Functors are just it's a function. You call it, it comes back. Whereas an RPC, you call it, and really you have to wait. There's going to be a callback function, which is called when it's completed. We'll go into that a bit further later. iList is a simple templated intrusive list class we use quite a lot. We use STL containers an awful lot, but sometimes you want something that's lighter and quicker, and it's an intrusive list, so you can have a list of anything that derives from the list element class that's in there. And they're a forward. So just a doubly linked list. There's probably one of the millions of implementations of that in the world. It's a bit like strings, really. We've managed to avoid defining our own string for C++.
Because we don't really do much with strings, though.
Yeah, but still, you have in terms of strings, there are C++ stood strings. In general, we've got Python strings floating around, and of course we've got datas which might contain strings. So we've still got three kinds of string in the system. Juice strings as well. We're in juice. So.
Is there another string for VSTs now use?
No, don't. Well, CF strings. You might be using a core foundation string from the Apple stuff. Yes, right to the bottom there. But
they can add another one.
They don't leak very fast.
I bet if you actually keep working through it, you'll find there's dozens of bloody different things.
Yeah. Log is the basic logging function, a log message call, which looks like a C stood IO thing. This is the basic. There's PIW sets up the loggers so that the logs go to the right place.
Is this deterministic? So is this deterministic? So does it, for instance, cut after a certain number of outputs? So I know how long it takes.
Actually, logs get stuffed onto a queue. Actually, so even if you log from the fast thread, it's actually going to get stuffed into a queue and output asynchronously. So it's not.
There's no guarantee of time.
Yeah. If you really need synchronous, you should use, go down to printf or something, but that will shaft your performance.
Yes. Post your system.
So it's not advised to use that in the release code in the background?
Well, no, not in any great big way.
Don't log anything from the fast thread in release code if you can avoid.
If it comes out once every few minutes or something, and it's only one, but if you're logging something every clock cycle, the system will stop.
You chose not to do it with macros, because macros you could then turn it off.
Yeah, well, it's been it's been down on the to-do list is to kind of factor it out and build a nicer logging system in at some point.
My experience is 10 log messages from the parse thread, and you can pretty much play one note perhaps. So it's a bit more expensive than polyphony to write a log message.
Yeah. Mlock is it's just an abstraction for pinning memory, so that it doesn't get swapped out.
Do we still use that?
Yeah.
What? Mlock.
Yeah, well, mostly you don't notice it because you're using it indirectly in other ways.
So called
Yes, yeah. I mean, but the actual allocator uses this stuff to implement it because Windows doesn't have an mlock call. That's something else. No copies, a simple utility class we use. If you inherit from it, it essentially just has private copy constructors. So if you inherit from it, your object becomes not copyable. If you have something that you shouldn't copy, it's a good way of enforcing it in C++. Platform.h is well, does that. not very exciting. And power is to do with, again, it's an abstraction for some power management stuff. Not very exciting. References we use. This class contains templated smart pointers for reference counting. Yet another implementation. The thing is, it's usually easier to roll your own than it is to pull in some big library and all the dependencies thereof.
I've got I've written it 4 or 5 times.
Yeah.
You always do.
How many of you? Yes, you've written. There are base classes for the reference countable object, depending on whether it's going to be atomic reference counted or unthread safe. I think that's somewhere else. Okay, yeah. That's just that, and it's a normal templated smart pointer class. Resources gives various functions that figure out where things are, like your library directory, and the Eigen main directory, stuff like that.
So we should be using that for anything directory related. We shouldn't directly construct paths.
No. You should use the facilities in here, or there's a Python module which uses this in turn.
It gives you the stuff in Python.
Yeah. SafeQueue is another templated. It's basically a stack which is done using atomic operations. So it's safe to push things onto the stack. It's used internally quite a lot.
Is it a queue or a stack?
It's a stack. I know. Yes, I know. Well, it's called a queue because it's implemented as a stack, but it runs as a queue. So you can drop things onto the queue atomically. So it means you can have a queue and the fast rate can post things onto it without worrying about blocking. There's also a thing for servicing the queue, which actually pulls the queue, inverts it, and pulls the stack, and inverts it and runs it as a queue. The trouble is with a lot of the atomic operations. I don't know if you've done much atomic stuff. Atomic algorithms for data structures are quite hard, and most of them, a lot of especially simple ones, they suffer from something called the ABA problem, which is quite subtle, and it's easier to we tend to often use a sort of mixture of reference counting and things like stacks to get around that problem. There are some very subtle things that can happen with these lock-free shared data structures, and we just have a few simple ones that we know work quite well. No idea what stack is.
Probably a queue.
It's a stack. I didn't write that. I don't know where that came from.
Because someone thought, I need a stack. There isn't one.
There's a queue. There's a queue.
Yeah. Well, yeah, but from a quick, I might rather just remove that. I'll have a check look. Because a quick look, that's using atomic things, but it's not ABA safe, so it's gonna you're asking for trouble using it. Studint is there because Windows doesn't have a studint header, so that's.
It doesn't make you just
Yeah, I know. It's a cry. Now, we use STL a lot, and if you want to use STL in the fast thread, remember that anything you use in the fast thread needs to be in locked memory. This STL defines an STL allocator class that you can use with STL objects that will pin them down into fast memory. Then it also defines some type defs for kind of locked maps, sets, multi-maps, vectors, things like that. Strbase is just some macros for kind of working out the address of a structure from something that's inside the structure or vice versa. Also quite boring. Table is a functor that no, it's just basically it's an interpolator. It's an interpolation function. You can give it a table of entries, and it can interpolate between them. So that's used. We do have a functor, which is quite things like the pan functions in the mixers and things, or pitch bend curves, things like that. What we often do is define the function in Python, because it's very convenient to test out new functions. Because it's Python, you can't use it in the fast thread. So there is a thing that you can take a Python function and it will sample the function into a table and then give you a functor that does the same thing by interpolating the table as a fast thing. So for pan curves and stuff like that, we use that a lot because it's much easier to write a pan curve in Python, and you can define the table. You can build a table with any resolution you like. And it just
So basically, if you give it a curve, it'll turn into a table which you can use.
yeah, and then it just linearly interpolates between them, and you just choose enough points to. I mean, it's linear. It's not smart. So you just if you have a thing that bends in one place, you're going to need a dense table.
Yeah.
But
if you want to do PWM, sorry, wave table. You could define a function for what the wave looks like in Python.
I suppose you could, yeah.
Call it.
Yeah, I'm not sure if linear interpolation would be your friend there.
No, I don't think it would be your friend.
For kind of
smooth functions.
Right.
For smooth
for kind of pan curves and stuff, it works quite well.
Something you
But,
want on the actual audio data. And
Yeah.
I think that would be very cool.
Yeah. I like the concept of at least sort of calling it and having it like that.
Yeah, yeah. I mean, you could have variants on it that did smarter interpolation. You sort of splines and beziers. Yeah.
Yeah, that's
Same thing.
nice.
So it doesn't have it runs more or less. It doesn't run in code during the running system.
Well, it's just that the fast thread, which can't run Python.
No.
It builds the runtime,
Yeah, it builds a runtime.
runtime. So you can use
Yeah.
nice stuff.
Yeah, if you look in the mixer, you'll see pan curves done like that. And it's a lot easier to mess with pan curves if you can just change a bit by.
And if you're doing something experimental where you want to play with it quite a lot and stuff with, it's just a very good way of doing that.
Yeah.
And it's not then subsequently so inefficient that you can't just leave it there.
So this is, normal threading operations, but just cross-platform. So threads, mutexes, etc., that sort of stuff. Quite light wrappers over the top. MacOS and Linux are the same here. They're both pthreads, so there's a pthread implementation and a Windows implementation. That does for macOS. Time is, again, implementation to clocks, to high-resolution clocks. Most timestamps we use microsecond or nanosecond clocks inside, and there are various ways of getting such data out of the system. So I think that there's essentially the main calls in there. There's a microtime function which will give you a microsecond clock, which is what we use for most timestamping. And there's a micro sleep function for sleeping for very short amounts of time, if you need such a thing. Tool is an abstraction for running other programs as sub-processes or whatever the platform defines, as all bizarre Apple bundle applications or
So this
things
might
like
be
that.
what ends up doing your...
This is essentially this backs the menu in Eigen that runs Stage and Workbench.
So if John was putting Eigentab, what Eigentab is a menu entry and as a run in the browser, that would be weird.
Yeah, well, if you write a program that did it, you'd have to write a program that embedded a browser to do it.
Yeah, that would be like a 10-line program.
Yeah. On the other hand, you could do that in Juice, and Juice has an abstraction for running a browser, I think, and you just give it a URL. So,
Okay.
yeah. USB is actually our USB abstraction, which probably doesn't. It's probably too high level really to belong in PIC, and I might well move it out at some point. It's quite big and complicated under there. Weak is a weak pointer system, which is, you know, well, everybody knows what a weak pointer is, I'm sure. Windows, no idea what that is.
I've got no idea what a weak pointer is. What is a weak pointer?
It's one that can be cleaned up by another part of the system, or you can specify one to say, I don't mind if it suddenly disappears.
Oh, okay.
Like a normal reference counting pointer, the object you're pointing to stays around until the last reference comes in.
Yes.
Weak pointers, the pointers don't control the lifetime, but when it goes, they get notified. So it's a pointer
Okay,
that
so
stays
it's like
good.
halfway to a reference counting pointer.
Yeah.
Okay.
And there's a thread safe kind of weak pointer in there. Right. No idea what that's for.
It's just all the.
Oh yeah, that's it's just some Windows map. Windows map.
Just Windows.
It's including some Windows files, but tweaking with the kind of define environment.
Define all sorts of if-defs of things which you don't want them to do. You
Yeah,
always end up with those files. Kind of like Windows Rush.
Yes. These other things are to do with event loops and things, and you know, Windows event loops, quite boring. That's the actual student for this function will indirect to the proper student if you're on a real platform, and the win student if you're on Windows. Don't know what xref is. I have a feeling that one is redundant, and I'll check up on that one.
It's kind of hostile.
It looks like another kind of weak pointery sort of weak pointery kind of
You're
thing.
not a lint user then, particularly. You're not a lint user then, are you?
No.
They tell you that.
Did you see that talk by the guy who runs ID software about using static code analysis tools and what it did to the game environment, which is because they do Quake down there. And it was an absolutely fascinating article about just how many mistakes they found using modern static code analysis, particularly the Microsoft tool that came with Visual Studio, sort of the Pro version that cost an arm and a leg, was incredibly successful at finding real proper bugs that they hadn't found otherwise.
When I've tried using stuff and I kind of gave up after a while, just because it meets this stuff that, you know, this kind of threading that's not protected by mutex and things, and a lot of code just drops dead at that
It
point.
assumes a thing about the form of your code
Yes.
and the architecture.
Yeah, which is not true if you're doing that stuff.
Especially if you're mixing languages as well. Like
John Carmack, that's his name, isn't it? Is it John Carmack? Yes. Yeah.
I mean, in the early days, we used Valgrind an awful lot. You know, I think that was a wonderful thing. But then we started using atomics quite a lot, and it just died after that. So the only Python facility out of PI Cross is resource, which is, you know, again, it's just wrappers to this resource thing for finding useful places in the file system, like your library directory or the Eigenlabs resources directories and binary directories and things like that. So yeah, cross-platformy stuff. Now, of the other libraries, PI Agent is this is the Python. The Python side of the library that backs Eigen-D. It's a thing for creating the environment in which to host agents or in which to run code that's written around the PIW side. So it's really only of use if you're writing either Eigen-D or standalone agents. Then you get into this library a little bit. It's not actually that big.
By standalone agent, what do you mean by standalone agent?
Something like Workbench or...
Okay, so a big chunky thing that needs its own state model of the system and...
something that is essentially, if you're going to run code that's based around our PIW library, that assumes you're running in a certain context.
Yeah.
And this PIA is what creates that context.
Okay.
And there isn't, I mean, really, it's an event. It's a set of event loops. There's a fast event loop and slow event loops and things, and these effectively these create that thing. I mean, an environment consists of a fast allocator to use, a network implementation to use, and the actual event loops and things themselves. And you basically you create one and set it off, and then you can run code inside it, and that's all it really is. PI session is wrappers around there, which, again, useful things for standalone agents, but it's mostly things that are agent D. It's sort of it's separated. It's Eigen D2, but separated out a little bit because we do use some of these facilities in other things like BCAT and stuff, which use PIW. They are quite small things. They use
I
some of
noticed
this
there's
stuff.
upgrade stuff, Jim. If people write agents and then decide that they want to, in a subsequent release of that agent, add an upgrade script so that it will get upgraded because they've added some ports or they want to change something about its internal state, and they want old setups that use the agent to survive when people run it, where do they go for the tools and how do they figure those out?
Well, the upgrade tools.
Is that the tools?
Well, this is the driver that actually does that upgrade process.
Okay.
The way it works is, I mean, in each agent, apart from the main function, you can also define an upgrade function. Effectively, you get given the setup file for your agent. Sort of a database of key, state variable values, and you get an opportunity to tweak it before it's actually applied to your agent. And this is done before any agents are loaded. It's purely, you look at the setup file and mess with it.
This is when you load a new setup.
No, it'd be usle to have an example of that.
Yeah, unfortunately we've just locked out all of the upgrade code.
There's no upgrade code at the moment.
But the way there is a class you can use where each agent has a configuration version, which has been reset pretty much to 1.0.0 for 2.0 all the time. In the class, you can define an upgrader class, and you have methods in it. This is in Python, called kind of 1.0.2, 1.0.1, 1.0.1, 1.2, and it'll run them in sequence to get you from where you are to where you need to be.
The upgrade facility is the same as the one that's full, so they can just look at the...
Yeah, you could look, if you look in the 1.4 code, you'll see a lot of them.
Code in 1.4.
It'd be handy just as in the example or in the template one, just to have.
Yeah.
It's just because people will guerrilla it, and I'll just guerrilla it, and it's just that kind of thing.
Yeah.
It's handy just to have sort of a.
It's quite a nice
It's
system.
a well-behaved.
Yeah.
I mean, some of the upgrades we've done in 1.4 are quite wild and woolly.
And they've worked.
Because in the upgrade code for an agent, you do actually have access to the complete setup. So you can do, I'm going to move this port from here to here, so I'll go through all the setup and find anything that's connected to that port and tweak it, and do stuff. So you can roam over the whole setup.
So you can be quite supportive of users' upgrades, basically, to make sure that actually happens.
And
because then one runs after the other. If you take a setup that was saved for 1.0, for example, and then load that into 1.4, your mileage should be good, because every single upgrade script on the way will be applied one after the other.
We do the same with the database files for our CAD data, where we expect to be able to take up a...
How much time has he got left? 10 minutes, Jim.
Okay, right. So we're back to that's PI session. If you look at things like BCAT and stuff, they use stuff out of PI session, just to create a very simple environment in which they can use PIW things.
So all these B thing, not all of them, but the BCAT actually does its own environment where it's working. Okay.
Yeah.
Like workbench light, very light.
But yes, very, very, very light. That is big. I mean, BCAT is 107 lines. It's not, quite a few of them are that. So it's using, essentially the main thing that the command line uses, from the session library, PI session, there's this run session, which essentially will create you the whole environment that you need, and you give it a function to run in it. And some of the flags are whether it really needs a real-time fast thread, which Eigen has, but you don't normally need, and whether you need an underlying clocking system, which you mostly don't. Anyway, to PIW and PI, which are the main things. PIW is pretty much all C. Yeah, not very much. So these are the core of the tools you use in writing an agent and writing the C part of an agent. Quite a lot of these we are going to be removing from here in order to stabilize the API. Yeah, I know, the thing is an unfortunate, it's an unfortunate name even for me, but we can't think of a better name. No one else is
using PIW thing.
Yes, yeah. No,
What is a thing?
It's a thing, yeah, it does stuff. Anyway, I'll just go through them quickly in order. Right. That's it. Most of these things are wrapped, and so a lot of these are available directly in Python as well through the wrappers. So address is mostly just utilities for dealing with the internal addresses of agents, the things with angle brackets and stuff. It's for kind of picking those apart and finding some utilities for dealing with that. Agent. Is no idea.
We're going to run out of time in a minute.
Yeah, okay, all right, well, I'll skip over that. Not an important thing. As I said, I will be going through these and pruning out some old stuff. And aggregator is a bundle class. So, it's the same kind of thing you've been writing. It takes cookies and gives you cookies. What it does is actually it can take multiple incoming bundles and merge them onto one outgoing one, dealing with the clock merge at the same time. You also get a chance to give it functors to filter the event IDs of the events coming in. Often, if you're aggregating, you also want to put things onto the event IDs to create this aggregated thing. So it's a kind of many to one.
The sheer number of files we have here, we could be here for some hours.
We're going to lose half of them, so I'm going to skip over some.
Okay,
Right.
I'm just going to inquire as to whether it would be worthwhile for you, as you're going through and deleting all this stuff, to either write what you're about to say as a very short description of each one, if they're the tools that people are using.
Yeah.
So
Okay.
I'd rather than go through them all now.
Yeah.
because I think
All right.
it's going to be, we would be another half an hour
Yes,
doing that, going
right.
through all these.
So in short, though, there are a lot of bundle components in here that are just do general things to bundles, like aggregate them, split them, clone them, gate them in and out, stuff like that, kind of signal switching-y sort of things. Other stuff for dealing with kind of like light utilities. Also, some of the key functions are things like you'll see index, server somewhere, client. These are C++ wrappers around the basic objects that Eigen provides. Kind of state variable servers, indexes, RPCs, things like that. And there are a lot of stuff in here to do with, which are actually the guts of agents, which I'm going to be taking out because they're not really part of our API. So things like the stringer is actually a class in here, the bundle part. So the stringer agent just essentially plumbs that up. But they're mostly to do with bundles or thread communication or just kind of old utilities.
I think it would be great to have some sparse documentation of this, Jim, because it doesn't have to be rich, but it would be nice to actually have an understanding of what people should need to write again.
Yeah, it is. It's an agent toolbox, and that's what it is.
Can I just ask, the PIW table is the interpolator, isn't it?
Yes, I believe so. I think that one is actually does the functor part of it, so it actually gives you the functory stuff. This is the PI library, which is Python. And here we have the much higher level things, the things like the atom classes, and so Python tools for doing many of the things that PIW can do, and some higher level things than that. And there are some things that are here because they're the general cross, like the plumber. The plumber logic is here because it's shared between Workbench and the interpreter. Okay. There's one thing I wanted to... yeah, 4 minutes.
Three actually.
Has anybody used Twisted?
Yes.
Yeah.
Yeah.
Okay, Twisted has a thing called deferred,
Yeah.
right? Where asynchronous operations return a deferred result. We use the same thing. We poached it straight out of Twisted. So things like RPCs return a deferred result, which is quite useful. It's easier than writing cladding callback functions that you pass in. There's a really cool thing you can do with that in Python, which is a coroutine. So if you've got a function that then has to do lots of things and wait for them to come back, you can write it as a linear function in Python, turn it into a coroutine. So you can call an RPC, you get the result, and you yield it up. And you'll get shunted sideways until that's done. That makes, if you're in an agent and you need to do lots of RPCs to different places, it makes it really clear and easy rather than horrific, which it would be otherwise. So looking at async, where that stuff is worth a thing, and looking at some of the code that does it is quite a good thing. Other than that, the bundle stuff, which you've sort of seen. There's also there's some PIW, there's bundle stuff in here, which is the basic. Bundles have endpoints, so you have a bundle upstream, downstream, an event receiver, an event sender, and that's all a bundle is. I think that's all we've got time for.